Hello, welcome to the video on proportional volume of similar solids. Basically, what we learned about similar solids is that if two solids are in fact similar, then we know that their volumes are going to compare in the ratio of one of the measurements in this figure cubed to one of the measurements in this figure cubed. We said this, we wrote it as this, m cubed is to n cubed, where m over n is the ratio of a measurement here to a measurement here, compares to the volume of the figure with m in it. I'll say volume of figure m to the volume of figure m. That's what we learned in class. Alright, so how we'll set this up. First of all, we need to actually verify that these figures do seem to be similar. Okay? If these figures are not proportional, then they're not similar, then this rule won't work. So the first things first, set up the ratios so that we know that these figures are in fact similar. You can pick any one of the four measurements that were given in these two cones. I'll start with the 8 feet, the smaller one. 8 feet. Well, in the small cone, 8 feet compares to 16 feet in the big cone. And I set that equal to, well, I picked from the small cone first, so I pick another measurement, 15 feet. And this lateral height here of this cone matches with this lateral height of this cone here, 30 feet. So I paired a radius with the radius, lateral height with the lateral height. Okay? And now all I have to do is make sure that these give me the same fraction, the same decimal. 8 divided by 16 is 0.5, a half. 15 divided by 30 is a half. So these are in fact similar as far as we can tell. Okay? So since they seem to be similar, let's actually use this ratio. We have m cubed over n cubed. This basically means pick one of the ratios you just used. Okay? Pick a comparison between the two figures. Either the radius to the radius or the lateral height to the lateral height. I say just use one of these. It doesn't matter which one you use. I'll go with 8 over 16. So we've got 8 feet over 16 feet. And since we're comparing volumes and not just areas or not just parts, we have to make sure we cube the two measurements that we have here. So this is cubed and this is cubed. On the right side, it says the volume of figure m. Well, I took 8 feet here from this figure, and so I gotta see if I know the volume of that one. Let's see. The volume of this figure is 850.4 feet cubed. 850.4 feet cubed. The volume of the figure that had the 16 in it, I don't know. I'm going to leave that as v. Now from this point on, I can cross multiply and solve. So 8 feet times v, so 8 feet cubed times v equals 16 feet cubed times that times 850.4 cubed. So that's the cross multiplication. This times this times this. Solving is pretty easy. You want to get v alone, so you will divide by this, 8 feet cubed. In class, I know we left out the measurements, so in class if you just leave these measurements, or the units out, that's fine. You'll just have 16 cubed, 8 cubed, and 850.4. And then all you gotta do is divide. 16 cubed times 850.4 divided by 8 cubed. When we do that, we will get our answer. So I'll type 16, actually, don't you watch me type it. 16 to the third times 850.4 divided by 8 to the third. And I get 6,803.2. That's the answer. Volume is 6,803.2. I know that this feet cubed and this feet cubed canceled. I was left with that feet cubed. So my answer is 6,803.2 cubic feet. That's the answer for that. And now we can tackle the second problem. So this is a problem where you need a volume, you're given a volume, you're given some measurements. The other type of problem that we work with looks like this. There we go. A problem like this, I'll give you both volumes, and I'll tell you right off the bat, I don't have it written, but in a problem like this, I would tell you these solids are similar. Alright, so I'm telling you these two rectangular prisms, these two, they look like cubes, but they might be rectangular prisms. I'm telling you these two are similar solids. So we can set up pretty much the same ratio. We pick a side in either one. Well, I know this one's 6. So 6 inches. I'm going to leave the units out this time, and I'm just going to put the units back in at the end. I know that since I'm going to get a side, it's going to be in terms of inches. 6 relates to whatever this is. Since I don't know it and it's a side, I'll say S. S, I have to cube both measurements of the figures. Okay, m cubed over n cubed. Equals the volume of whichever figure had the 6 in it. That's 336. Over the volume of the figure that had the S in it, the unknown, 5,250. And then we can cross multiply. Okay, that's the whole setup. Okay, that relates to that, that relates to that. So S cubed times 336, S cubed times 336 should equal 6 cubed times 5,250. 6 cubed times 5,250. And this is pretty easy to solve. You want S alone, it's being multiplied, so the opposite would be to divide. Divide by 336, divide by 336. These 336s are going to cancel out, leaving me with S to the third power, or S cubed. On the right side, I need to actually do some math on my calculator, which I'll put right here so you can see it, I think. Right there. Okay. So I have to type 6 to the third times 5250 and divide by 336. Alright, right there you see it. I hit enter and I get my answer. It is 3,375. Okay, so I know that S cubed is equal to 3,375. That's not S though, that's not how long this side is. That's how long this side times itself is. So to get rid of a cube, I told you guys before, you have to take the cube root. Here we take the cube root as well. On the calculator, how you get that is you hit the math key, which is right where my finger is right now, and then you go to the fourth option down. Okay, the cube root would be right there. Sorry, I can't see in the reflection. Hit enter on that, and then you can type 3,375. 3,375, and you will get your answer, 15. That side is 15 inches long. It's fine if you leave the units out while you do it, as long as you put them back in at the end. And that is just about it for proportional volume. Right? So again, your ratio is side, length, edge, radius, whatever, of one figure cubed compared to its corresponding side, length, width, radius, whatever it was, cubed. They have to be the same, like they have to match up. They have to correspond. 6 went with this. If I gave you this height, it would go with that, so on and so forth. Equals the volume of whatever you took from here, like the volume of whatever this figure is, since you took it from this guy, volume of figure M over the volume of figure N. That's roughly what the formula is. Okay? I hope this video was informative. If you have any questions, feel free to leave a comment in the box. Feel free to email me. Feel free to ask me in class, and I'll get back to you as soon as I can. All right? Have a great day.